Alright, hello everyone. I thought I'd do a quick video over make, and for the sake of time I'm not going to really talk about why you'd want to use make, but I'll put a little blurb in the description about kind of what it has over a shell script. But so let's talk about how you would write make files to build your projects. I'm going to do this outside of a C context for now. I want to get the fundamentals of make through in a way that you see how you could use this outside of just compiling normal code. In this case, I'm going to be converting a markdown file to a PDF. So a simple make file consists of rules with the following shape, like so. You have your target list, target file, or multiple target files, a colon, and then your prerequisite files. Then you have your recipe, and your recipe is actually what make will execute to create your target file. Two things to note. If you're going from here for your recipe, you do need tabs. It will not accept spaces. It's just a quirk of how make was made. And your first target in your make file is what is run if you simply typed in make. Other ones you can do like by putting in target specifically, but we'll get there in a moment. So let's look at this project. So we have a markdown file, like so, and we're trying to create a PDF, like so. So what we're going to do is we're going to make a kind of start off with converting the markdown file to a text file, and then we're going to convert that text file to a PDF, and we're going to talk about how make works along the way. So let's start with this blank make file. So what we need to do is firstly we need to make the tag, right? So let's do that here outside of make, so we know what we're doing first. So if we run common mark /type latex hello world.md, it'll output this this latex right here. Now we do need some boilerplate above and below it, and for the sake of time I'm just going to copy paste that in, but this is enough to get us started. So our output file, our target, is hello world.text. Our input file, or our prerequisite, is hello world.md. Tab, and we have cmark/t latex hello world.md, and we want to put that into hello world.text. Alright, so now I'm going to bring up that LaTeX actually has built-in variables. Or sorry, not LaTeX. Make has built-in variables in its make files. So as you can tell, hello world.md is the same as our prerequisite. So we actually have a built-in variable that we can access. $signs access variables. And if it's a single letter, you don't need parentheses, but I'm going to put everything in parentheses for the sake of clarity. So your prerequisite you can refer to with this caret. So you could also refer to this without the parentheses, but I'm going to keep them for the sake of clarity. And then your target you can refer to with an @. Again, you don't need these because it's only one character, but we'll get there in a moment. So this is fine. So I'm actually going to run make here, and we're going to check hello world.text. Alright, that's great. Now if we run PDF LaTeX on it, we'll actually get an error because we have to put in some boilerplate. For the sake of time, I'm just going to copy paste that in. It's nothing too complicated. I'll run it and we can take a look, like so. And then we have to put in an end document tag as well. And I want you to note that I'm using these same variables. Let me put in some parentheses here. So if I run make now, oh I see. So I'm just going to touch this file so it recreates it. This is our full document. We have document class, letter article, begin document, and this is the stuff from the markdown file. Great. So let's expand on variables a little. So make has two types of variables. We have recursive, and we have let me make sure I get my terms right. I think it's called simply expanded variables. So a recursive variable, so let's say we want to replace cmark with a variable called mark, so later on we can change it. So we would call that variable like so. And it's important to have the parentheses here because if you remove them, it would actually only register $m as a variable. So if I run make, or I have to oh whoops, did I mix something up? There we go. So we'll try to run this command called arc, which is everything after the m, but obviously that doesn't exist. We're trying to call a variable, so we have to put that in parentheses. These, because they're only one character, you don't actually need that, but I'm going to keep them like that for the sake of keeping everything consistent. But let's say we want to take it a step further, and we want a PDF mark. So we don't want to have those flags there. So then we can do mark /t latex, and we can replace that here. Right? So then if I run make, we get the same output. That's great. There is one thing to note, and we'll get back to this after we do the PDF step, but the problem with these recursive variables is actually that they don't just plop in the text, they have a reference to the variable. So if I try to do something like this, where the variable references itself, it will not be cmark /t latex. It will actually be infinitely recursive. So if I try to make, it'll give me an error that the recursive variable references itself eventually. You don't want that. So that's what simply expanded variables would do. What's interesting though with a recursive variable is, let's say I change mark to, like some random option. I don't know, whatever. Then PDF mark actually updates as well because it's a reference. So here PDF mark will be is cmark /o/t latex. So it'll update when you update mark, even though you update it afterward. A simply expanded variable to me personally makes more sense, where let's say we have the same one, but we only want it to update once. So this is the POSIX syntax, the standardized syntax of how you would do this. GNU Make also supports the same syntax. These are equivalent. And this one, if I change cmark to whatever, at this point PDF mark is still cmark /t latex. And what this means is also I can do like so, and I won't get any errors. Right? Because it's no longer recursive, that didn't actually mean anything. I can do it like so, and it isn't recursive because it actually just plops in cmark, like you'd kind of expect. So that's variables. Let's quickly do the output step for PDF, and then a quick clean. So our target would be hello-world.pdf is our output. Our input is actually hello-world.tech, which as you can see is what is made down there. And then our recipe is simply PDF latex, and we can call it, we want to run it on our input, which would be $@ if I'm not mistaken. So we can run it, and now you can actually see that our default, the target we run by default because hello-world.pdf is on top, will be that one. Missing begin document. Okay, let's take a look at what's going on. Oh, I think I blundered which one I was using. There we go. So now we've created that PDF file, and let's, going off of our variables, we'll do a quick variable for latex, which we can use either for here, which will do PDF latex, and so we will have it like so. And there we go. And so let's do a quick clean function, which is customary, where we're going to just remove all of the files. So we remove, let's take a look at what we made. So we made hello-world.tech, we made hello-world.pdf, we made hello-world.aux and hello-world.log, and this -f flag just says if they don't exist, don't yell at me. So if I make clean, we return to our initial state. We clean out the files we don't need. So I think that's everything that you need to get started. If you're working with something like a C project, there's a lot of implicit rules that are useful that I'll go over in the next video. But hopefully in general, you get the idea now. And also, just quickly to hammer it through, if I make this recipe will actually call this one because it knows that I require hello-world.tech and that this is the recipe for hello-world.tech. So in that way, it's very useful that it can correctly kind of deem what files you need to create. And if I don't edit anything, it won't waste CPU cycles recompiling. I can edit just the tech file, which will update the PDF, like so. But note that will get overridden if you update the markdown file. So if I make there and if I update, you can see that whatever I had in the tech file got overwritten. So hopefully that's a good overview. I'll put kind of a brief description of Make in the description, as well as a blog post that I think is really useful for practical applications, and the GNU Make manual if you want a more verbose understanding. Thanks for watching, and I hope you have a good day.